Hello everyone, my name is Mohammad Rabiul Alam. My student ID is ST20316895 and today I am presenting my MSc project which is based on zero-shot learning driven NLP framework for hyperautomation and ITSM IT service management service desk operations. The main idea behind this work is simple. Can you use zero-shot learning and NLP to automate the service desk incident handling more intelligently, and especially when new incident types appears and the model has not seen them before? So let's get started. So I will start by introducing the problem and why it matters in modern IT service management. Then I will cover the aim, objectives and research questions, followed by the methodologies and proposed framework. After that, I will present the key findings and discuss the implications, limitations and future work. And finally, in conclusion, I will conclude with the overall contribution of the research. So, what is my background and the context of this project? To begin with, the enterprise IT environments are becoming more complex every year. Service desks now deal with high volumes of incidents, and many of these are still traced in manually. That creates delays, increases workload for support teams, and pushes MTTR higher than it should be. And also, the problem statement comes with is that the most current IT service management automation still relies on the supervised machine learning that works only when the model has been trained or all the relevant categories. But in real service desk environments, incident types keeps changing, and that creates a cold start problem when new categories appears. Then I'm going to discuss about the research gap. When I reviewed the literature, I found that the most studies focus on supervised natural language processing classifications using fixed and like a category of sets. But what is missing is strong evidence that zero-shot learning can work efficiently on real IT service management data. The gap is what made this research worthwhile. My research aim was this project was to design, like implement and evaluate with the zero shot learning driven natural language processing framework for hyper automating IT service management, incident classification and trace out the continuous retraining. In other words, I wanted to build a system that could still make sensible decisions even when it encounters unseen incident types. To achieve that aim, I have to set 5 objectives. First, to design a zero-shot learning-based automation framework. Second, to test it using the ServiceNow dataset. Third, to compare it with a supervised BERT baseline. Fourth, to measure the effect on MTTR, and the fifth, to produce the practical recommendation for the deployment. And my research questions are the study should guided by 3 research questions. Like I wanted to know how well the zero shot learning performs on unseen incidents, how it compares with supervised BERT across familiar and unfamiliar categories, and how much it improves the operational efficiency through MTTR reduction. These questions helped me to evaluate both of the technical and practical sides of this framework. This study matters for 2 reasons. Academically, it is one of the first large-scale evaluation of zero-shot learning in IT service management. Particularly, it addressed the cold start issue, which is a serious barrier to service desk automation, and it supports the development of systems that are more adaptive and scalable. The dataset used in this research was the ServiceNow incident management dataset from UCI machine learning repository with a 141712 incidents, and that gave the study enough scale to support a meaningful evaluation. And I also used a composite level of structure based on the category and subcategory support classification. The exploratory analysis showed that the resolution time is not evenly distributed. Most incidents are resolved fairly quickly, but smaller number take much longer, which creates right skewed patterns. This is reinforced and need automation because it shows the inconsistent manual handling can be. Methodology I used to design science research. I chose approach because the project was about building an artifact, testing it, and also evaluating its value in a realistic setting. So the focus was not just theory but also practical solution development. The proposed framework has four main parts: incident ingestion, zero-shot classification, knowledge-based mapping, and automation orchestration. So the idea is that the incident comes in the system, interrupts it as simultaneously, like maps it to a likely category and then routes it automatically. So the zero-shot learning engine combines sentence like BERT and BERT MNLI, which sentence BERT helps measure semantic similarity between the incident text and category descriptions, while BART MNLI checks whether the incident logically fits its candidate level. Using both together makes the classification more reliable, especially for the unseen cases. To make the evaluation fair, I used fine-tuned BERT model as the supervised baseline. So this model was trained only on seen categories, which makes it a strong benchmark for comparison. It represents the standard approach used to many incident classification in the system. The experiments used a seen versus unseen split, so I could test the generalization properly. I also kept preprocessing and the data prioritizing identical across the models to ensure the fairness and uh, through to ensure the fairness and reproducibility. So here the macro advantage metrics were used because the dataset was imbalanced. The main technical result is that the zero-shot learning model achieved an overall F1 score of like 0.77, which is a solid, and given that it had a deal with both seen and unseen categories. The supervised BERT model did better on the seen categories with an F1 score of 0.84, but it could be handled on unseen incidents in the same way. So the key point here is that zero-shot learning is more adaptable while BERT is more accurate on the familiar levels. The error analysis showed that the most mistakes happened when the categories are semantically very close to one another. That is a common issue in zero-shot systems because similar levels can be confuse the model. A particular improvement would be developed here to refine the level and description to make the category definitions more distinct. The operational impact is one of the strongest parts of this study, while manual tries produced MTTR of 120 minutes, while the automated framework reduced that to 15 minutes, which is an 87.5% improvement. In that particular terms, that shows the framework can make service desk operation much more faster and much more efficient. The findings suggest that zero-shot learning is a realistic way to improve IT service management automation in changing the environments, but I do not think it should be completely replace the supervised learning. The strongest option is hybrid strategy. We can use the zero-shot learning for a new or rare incident type, and the supervised models for the routine categories are overall understand. There are some limitations in my work. The three main limitations are like it's a study-based single dataset. Second, Secondly, I should mention the resolution workflow is simulated rather than the deployed live. And thirdly, the effects of the performance. And feature work should be tested on this framework for multiple data sets in live service now or live environments and over longer periods. So whatever I have discussed here, let's conclude them. This research shows that zero-shot learning can be help solve the IT service management cold start problem and improve the incident triage in a meaningful way. The results support the idea of a hybrid automation strategy and showed the clear academic and particular value. Thank you for listening, and the full references are included in my dissertation report.